What is the true percent composition of NaCl? I wrote this to say true percent composition of NaCl because when we talk about percent composition in chemistry, we talk about percent by mass. So that if you look at that and say, well, there's just one sodium and one chlorine, it's got to be 50% sodium and 50% chlorine. That would only be true if sodium and chlorine weighed the same amount. So when we find the true percent composition, we're talking about the mass composition. So what we need to do first in any example of these is to find the atomic masses of each element. So in the case of sodium, it's 22.99 atomic mass units, and for chlorine, it's 35.45 atomic mass units. You may also see this in some books listed as mu, which is the same thing, just a different symbol for meaning atomic mass units. So the next thing you want to ask yourself is, how many of them do you have? Well, in this case, we have one sodium and one chlorine. No subscript means just the one, so multiply each of those by 1, and that's easy enough to do. And we get those two numbers there. That'll be helpful. It doesn't seem very illustrative to just multiply them by 1, but had it been something different like 2 or 3 as your subscripts there, then these numbers will be useful to you when you're finding your percent here in the end. So we'll do it just out of good practice. Now, to find the total mass of the entire molecule, NaCl, we need to add these two things up, and which is what we would do if we had to multiply by any other number than 1 in the same case. So if we do that, we get 58.44 AMU. We're almost done at this point. Percent composition, any percent is always a piece over the whole times 100. So in this case, the whole molecule, or a whole compound here, weighs 58.44 AMU. We know the sodium piece weighs 22.99 AMU, and we know the chlorine piece weighs 35.45. So to figure out the percent of this compound that's sodium, we use the formula percent composition equals the sort of atom or atoms over the compound weight times 100. So in this case, sodium is going to be 22.99 all over the total compound of 58.44. Times that by 100. All percents are a fraction times 100, and you get 39.33%. So almost 40% of sodium chloride by weight is sodium. And you might be able to figure this out without doing any more math here, or any more real math, is saying, well, since all the rest of it's chlorine, you can subtract the 39.33 from 100. But let's just do it out anyway. We take the mass of the chlorine, 35.45 AMU, all over the total for the compound. Again, note that those numbers are the same because we're still talking about sodium chloride, the total compound. So that bottom number won't change if you're still talking about the same compound. And we do that out, we get 60.66, which makes sense since if we add that up, that's 99.99, which is basically 100%, or meaning we've accounted for the total molecule, everything in it.